Hello everybody, welcome to this online course. Prepare for calculus examination. Questions and solutions hand by hand. I'm so glad that you're here, but before we started, and to prevent from wasting your time, we have to understand, whom the course is made for. The course is made for the students or graduates who do not have solid knowledge of advanced mathematics. To say the advanced mathematics earlier, we talked about the calculus 1, 2, 3 in the United States, and also the linear algebra and much more. But basic ones are the calculus, which is included in this course. Alright, so this course is also designed for the people who wants to improve their calculus skills. Maybe you feel that my skills are limited. For maybe very basic questions, I understand. But for problems which is a little bit more complex, I'm confused. So this course is right for you too. Okay, so if you're a student who do not have any knowledges of calculus, such as the students who just attend the first year of your college program, you want to set up your goal as to learn the calculus pretty well, I think you can choose this course too. And also, this course is for the people who are, have very limited time, such as maybe several months to prepare, and also you want to pass, the tests, such as the school tests or the standard tests, such as the ones from the ETS. You can also consider this course. Alright, the next point is about the education style from me. So the course here is going to be very systematic, but also going to be very specific, because we're going to talk about all the key points, which is very useful in calculus systematically, but we're going to give you the examples all the time and a very detailed explanation. And also, this is a very serious course, but I will trying to inspire you, to encourage you to take it and be successful. And also, I'm gonna use my hand, use my pen to give you the explanations, and hopefully you can do the same thing too, because there's no way for a person to learn the math well, just by reading the books or just watching some videos. You will have to write it down, just like what I do here, to really master the math. Alright, so now let's continue our conversation about how to be successful here. So you have to take notes, of course. You have to practice on a piece of paper, and you have to think about every concept and every deduction that I make here. You have to mimic and write down by yourself too. And always review your notes if you have any question when you are in a new sections, but you have a confusion about the old knowledges. You always have to review. Okay, so your task here. Now we understand that I'm gonna introduce the concepts, knowledge, skills in different sections. So I want you to understand the fundamental concepts, theorems, formulas, and also grasp the basic methods and skills used in used in calculus. And of course, some knowledges are, specially designed for calculus, but they are popularly used in other aspects of mathematics, like in your middle school math or the high school math. If you have trouble with them, you can always refer to your middle school or high school textbooks. Alright, so in calculus, the basic abilities include the limit, derivative, and integration. So that's why we're going to talk about them in sequence, from the very basic limit all the way to the integration. Alright, so our goal is to have you establish the basic calculus knowledge structure in your mind and also form your own fundamental mathematics thinking quality. So hopefully this can be a very good training journey for you. Alright, so in this course, we're going to talk about the following content. In the first section, we're going to talk about the limit, which is the basic, knowledge for calculus. And then we're going to talk about the single variable differential and also assister, or the upper, the other side of the differential, which is the integral. And then we're going to talk about a version for the multivariable calculus. And then we're going to do the reversion again. We're going to, do the differential equation based on the knowledge or the skills of differential and integral. All right. So now let's get into the first section, limit. In the limit, we're going to talk about the definition of it, the property, the calculation methods, and also we're going to do the implementation introduction to have you see why we have to learn limit and why it's the base for the differential and also for the integration. Alright, let's jump on to the topic of definition of limit. So we have different types of limit. So why don't we start from the function limit? What is it? Remember, we have many examples, maybe from the high school, such as a function like this. Okay, so this is a function f(x). Unfortunately, it does not have any definition on the point x, 0. But from the observation, we can see that it can be very close to a certain, point. We call it a trend. So maybe, it's gonna arrive here, but actually it cannot. But from the observation, it could be. So that's why we can say, mathematically here, limit x approaching to fx, x0 for the function fx is a. So we say that, because fx and a could be very close, right? It can be here, 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 all the way to a. It can be very close. But close mathematically, how can we, express it in formula? Remember in the geometry class, maybe, you have a and b, right? So how do you measure the distance between them? Well, simply just do the subtraction between a and b, so we can get the distance. So similarly, we can do the fx minus a, which will give us the distance between fx and a. And we say that from observation, a d could be very small, right? But how can we describe the small number, the such trending, the distance between them is getting smaller and smaller? We can say that there's a number epsilon, the Greek letter, which is positive but very small. You can imagine it could be very 0.1 or 0.001 or 0.00001 could always be very small, right? However, such d between fx and epsilon and a could be very small, could always be smaller even than the small number epsilon. Alright, so that's how we describe the trend in the language and math. Okay, so let's see. Now we can say that, right? So this is talking about the distance fx and a is talking about things on the y-axis. But what about the projection of them onto the x-axis? So it means that we have this, right? This is approaching from the left side. You can also do the similar thing from the right side approaching. So it means we have a certain range here, and then we have a left limit called x minus epsilon. Epsilon is a small number, but it's also positive. Delta. Delta is like epsilon, which is positive, but also very small. and x minus delta for the right side limit here. Alright, so it seems like on the y-axis, right? The distance between the fx and a could be very small. No matter how small for the number epsilon you can imagine, the distance between them could also be smaller than them, epsilon. But on the x-axis, right? So it means there's always exist one number. We give its name delta here. Delta can always be within the range shown here, within the brackets. Within the brackets. All right, so let's describe it in the language, in the words. All right, so here, so you can imagine a very small number, which is epsilon, which is bigger than 0. So for any of them, there's always exist a delta, which is also positive, but it will give us a very small range. We call it a neighborhood in the calculus. So delta, so x minus x0, smaller than delta. Our distance means there's always a small enough neighborhood to satisfy such condition, which is given by fx minus a, the distance between fx and a smaller than epsilon. Yeah, so that's the definition, by words. So here, we have 3 different kind of definitions: by graph, by algebra expression, and then by the mathematics words. So, this 4-phrase definition is the key point. Gonna see similar things later for different types of limitation. So if you want to learn calculus well, please take the note, write down, and think about it. From the intuitive graph all the way to the 4-phrase sentence. Okay? So I'll see you next time. Thank you.